Hello, so welcome to the series of linear integrated circuit, and we are going to discuss about equivalent circuit of an operational amplifier. Equivalent circuit become very important when we are discussing about the circuit analysis of operational amplifier. So in this topic we will discuss that how can we represent operational amplifier as an equivalent circuit. So we will make its symbol. We will make its symbol like this is opamp, inverting terminal, this plus is non-inverting terminal. So the voltage here it is V1 and we are getting output from here. We know that this is the 6th number pin, this one is 3rd number pin, the inverting terminal pin, this is 2nd number pin, the voltage here is V2, and similarly we have two power supply. This is 7, that is plus VCC. Let's say this is CC. This is 4 number pin. Supply voltage is minus VCC. So in previous class we had discussed about PSRR. If we are doing any changes in this power supply, that should not be reflected to the output. So this terminal that we know, this terminal is inverting. This terminal is inverting terminal. Why we are calling it as inverting, that we will discuss. And this terminal is non-inverting terminal. Non-inverting terminal. So the difference of these two signal will be V input difference, VID. It is written as VID, V1 minus V2. And the input resistance will be between these two terminals. So this is the resistance, this is input resistance R in, and we have output resistance as this resistance is R out, and we will connect here a voltage source like plus minus. This is A into VID. This is A into VID. So this become the equivalent circuit. So output voltage can be written as A into VID. So we know that the gain, that is A, is the ratio of output divided by input, and in the context of operational amplifier we can write it as VID, since your operational amplifier is amplifying the difference of input signal. इनपुट के डिफरेंस को एम्पलीफाई करता है, तो इसलिए यहाँ पर जो इनपुट वोल्टेज होगा दैट विल बी VID. सो यहाँ से अगर हम आउटपुट देखें, द आउटपुट विल बी A into VID. A into VID. That's why this voltage source A into VID is connected to the output terminal, and in ideal op-amp we have seen that output resistance will be 0 and this input resistance will be infinite. जब ये infinite हो जाएगा तो ये दोनों टर्मिनल आइसोलेट हो जाएंगे, ये ओपन सर्किट हो जाएगा, और यहाँ पर करंट का वैल्यू इस टर्मिनल पर 0 हो जाएगा. Clear? So this is what is this AVID? AVID is basically the equivalent Thevenin voltage. We can represent any circuit as in Thevenin equivalent, we know that any circuit can be represented as a voltage source. This is plus minus. This can be written as VTH in series with a resistance, that is RTH. Any circuit, any linear circuit can be represented as a voltage source, that is VTH, in series with a resistance RTH. So this VTH is called as Thevenin voltage source. Thevenin voltage source, and this RTH is called as Thevenin resistance, and we can connect here the load. As required. So we can calculate these two terms. By simply applying the Thevenin theorem. Whenever we want to calculate this RTH, that is the Thevenin resistance. This RTH can be calculated when your voltage sources, all the voltage sources must be short circuited. That means should be 0. And similarly, current sources also be 0. That means open circuit. So by using this fundamental, we can calculate Thevenin voltage and Thevenin resistance. Here we can see that this is AVID. This is AVID is the Thevenin voltage of this circuit. This AVID is the Thevenin voltage of this circuit, and this output is the Thevenin resistance of this circuit. Output can be calculated by seeing here at the output side. We can calculate the Thevenin resistance. So this is the equivalent circuit. Similar in this circuit we have seen कि ये इनपुट हमने लगा दिया दोनों इनपुट टर्मिनल्स के बीच में. Since we are getting output as A into VID, so this is the Thevenin voltage. So this become Thevenin voltage VTH. This become RTH. So any circuit can be represented as a Thevenin voltage in series with Thevenin resistance. और whenever we want to calculate output, हम यहाँ पर एक load लगा देंगे, and then we will get the output. So so we can simply write here V output is A into, this is VID, that can be written as A. VID is V1 minus V2. So what is A? A is the gain, that can be written as large signal voltage gain. This is large signal voltage gain. And what is V1? We know that what is V1? V1 is the voltage at non-inverting terminal, and similarly this V2 is voltage at inverting terminal. And what is this VID? VID is the difference input voltage. This VID is the difference input voltage. Is that clear? So now we are moving forward to discuss that how can we make the equivalent circuit of an ideal op-amp. We have seen the characteristics of ideal op-amp. So similarly, we are going to make equivalent circuit. Similarly, we are going to make equivalent circuit of an ideal opamp. So in last class we have seen that gain should be infinite, open loop gain should be infinite, then input resistance must be infinite, output resistance should be 0, bandwidth should be infinite. We have seen common mode rejection ratio, this should also be infinite. PSRR, this should also be infinite, and sleeve rate should also be infinite. These are the properties. These are the properties of ideal op-amp. These are the properties of ideal op-amp. So we are going to apply these properties. So here we have input resistance as infinite. So we can simply make this op-amp as this is inverting terminal. This one is non-inverting terminal. And this is the difference, that is V1 minus V2. This terminal voltage is V2, V1, this is V2. So here we have resistance, R input, and that should be infinite, so it will become open circuit. So this will become open circuit, and here the output resistance will become 0. So this is simply the output, because here the output resistance become 0. So we can write, we can apply the formula Ohm's law, V is equal to I into R, and we are having resistance. Here we are having resistance as infinite. So I will become V divided by R. Since your resistance is infinite, so current become 0. That means no current will flow in this terminal. Be remember, no current will flow in these two terminals when your input resistance become infinite. So we can write here. So there is an open circuit. There is an open circuit between two terminals. टू टर्मिनल्स मीन्स इन्वर्टिंग टर्मिनल और नॉन इन्वर्टिंग टर्मिनल के बीच में हमेशा क्या रहेगा, ओपन सर्किट रहेगा. क्यों रहेगा? क्योंकि हमारा जो इनपुट रेजिस्टेंस है दैट बिकम इनफाइनाइट, और इनपुट रेजिस्टेंस इनफाइनाइट हो गया, दैट मीन्स करंट बिकम 0. दिस इज द कंडीशन ऑफ open circuit. So this is all about your equivalent circuit. How can we analyze the operational amplifier for different application? आगे जो भी हम linear applications पढ़ेंगे तो उनके analysis करते हुए हम ये याद रखेंगे कि we need to consider these all conditions, that input resistance is infinite, output resistance is 0, then only we will do the analysis. So this is all about the equivalent circuit. Thank you for watching, and the next topic of discussion will be the ideal voltage transfer curve of an operational amplifier.